One of the primary ways we use the reaction quotient is to tell whether a system is at equilibrium or not. Later, we'll actually use it for electrochemistry as well. One of the ways we're going to be using it is telling whether the system is spontaneous or not, because delta G of a reaction is equal to delta G naught plus RT natural log of Q. And so if we know the delta G of the reaction under standard state conditions, and we know Q, we can predict whether or not perturbing the concentrations will make the reaction spontaneous or stop it from being spontaneous. Very large Q makes delta G positive, very small q makes delta G negative. One of our first tasks then is writing the equilibrium expression and filling in the appropriate values. So we take a look at this example. We have the cobaltic chloride, cobalt going to tetrachloride, so Q will become equal to the concentration of the tetrachloride raised to its power of 1 in this case, aqueous cobalt, and the chloride ions raised to the 4th power. And then we can plug in the values for that, which is those given in the problem. So the cobalt tetrachloride is 10 to the minus 5th molar. The cobalt 2.0 times 10 to the minus 3rd molar. And our chloride is 4 molar raised to the 4th power. And once we have that, we can plug it into this equation, where delta G, as given in the problem, was 29 kilojoules per mole. And so the delta G of the reaction will equal 29 kilojoules per mole plus R, 8.314 joules per mole Kelvin times T, in this case 298 at 25 degrees, times the natural log of 1.9 times 10 to the negative 5th. When you multiply these values together, you get negative 26,933 joules, or sig fig wise 27,000 joules per mole. To add kilojoules and joules, they need to be the same, and so we will convert this one into kilojoules. 29 kilojoules plus negative 27 kilojoules gives us 3 kilojoules. Still, this would represent a positive delta G, and therefore the reaction would be non-spontaneous under these conditions. Find Q, take the natural log, correct the units, and you can solve for whether it's spontaneous or not.